Hello everyone. Today we're going to go over a couple examples here on your next assignment on acceleration and the distance worksheet. So if you take a look up here at the top whenever you open the form, acceleration and distance, please enter only the numerical value for your answer. Please do not include units. I do have some in there, but different variations can cause the answers to be wrong, and that's why I just want you guys to enter the numerical value only. A couple of the ones will tell you that placed around to most, the answer you should get should be a fairly easy one to enter into the Google form. The three equations that we'll use in here, if we're finding the distance when I have a period of accelerated motion with no initial velocity, gives me 0.5 multiplied by the acceleration multiplied by the time squared. If I'm solving for the acceleration, it's 2 times the distance divided by the time squared. And when I'm finding the final velocity, I take the initial velocity and I add it to the acceleration multiplied by the time. Again, here are the different equations that you guys will use at the top. And I'm going to switch over to where I can write on the screen. All right, important part is whenever you're going through, I start out with a data table every single time, because then all I have to do is plug into my equation, reading from the data table. I don't have to go up here and read from the problem anymore. So as I read, I'll start picking out important bits of information. The cat starts from rest. If it starts from rest, it's saying how fast the object is moving. Rest means 0, and since it's starting from rest, that means my initial velocity is 0 meters per second. It runs at a constant acceleration of 1 meter per second per second. That is how the acceleration is written on your form. It just ends up being easier to write. It can either be meters per second squared or meters per second per second. Lastly, it's telling me that they ran for a total of 3 seconds. How far? That's asking for distance. Now, out of my equations, when I have distance and acceleration, I'm using one of the versions up here. This just happens to be the equation rewritten for a different variable, so that all you have to do is plug into a calculator. Then down here, this is our equation for final velocity that we were using from the previous week. If I'm solving for distance, I want to use the one that has d by itself. So that means I want to use this first one that's listed over here. That is 0.5 at squared. That's going to give me 0.5 as I plug in my numbers. The acceleration is 1 multiplied by just the time squared. And I can type this right in a calculator just like it is. So as I pull up my calculator app, 0.5 multiplied by 1 multiplied by 3, and I want to press the square button before pressing equals, because I only want to square the time. I don't want to square the entire term. When I press equals, my distance then is 4.5 meters, and this is what I want to put in the form, 4.5. As I take a look here at part B, because all these problems are set up as part A and part B is asking me for what is the final velocity. I'm still going to be pulling information from over here at my data table from the original problem. To calculate the final velocity, I need the initial velocity plus the acceleration multiplied by the time. So if I want to find the VF, VI is 0 plus the acceleration, 1, multiplied by the time, 3. 0 plus 1 times 3, VF is 3 meters per second. And again, I'm only entering the number in the form. I don't want to put in the meters per second. That just helps with the reducing the amount of errors, basically by whenever you're putting in your units. As we take a look here at number 2, car is at a stoplight. Well, if a car is at a stoplight, it's not moving. So that tells me the initial velocity is 0 meters per second. And then it begins accelerating at a rate of 3 meters per second per second. 3 meters per second, that is our acceleration. Again, it can either be meters per second or meters per second squared. Both are the same thing. This one is a lot easier to type. Runs for a total of 20 seconds. Seconds measures my time. How far does the car travel? If I'm solving for D, I want to use the version of the equation that has D by itself. I want to write my equation down, 0.5 AT squared. I'm going to plug in my numbers. D equals 0.5. A is 3. And the time is 20. And don't forget about squaring. Plugging this in my calculator, 0.5 times 3 times 20 squared equals. That gives me a total distance of 600, and that's what I'm putting into the form. If I want to find the final velocity is VI plus AT. Initial velocity is from up here. It is 0. The acceleration is 3, and the time is 20. So 0 plus 60, VF is 60 meters per second. And the 60 is what I want to put in the form. I don't want to put anything else. Okay. One more example, then you guys will have the rest of them to solve on your own. A dog breaks free from its leash. Well, if a dog's on its leash, probably isn't moving too far, sitting still. It accelerates for a total of 32 meters. Okay, meters. Meters is a unit of length, a distance, how far it went. And it went a total of 8 seconds. What is the acceleration of the dog? If I'm solving for acceleration when I know distance, again, I want to use the version of the equation as acceleration by itself. I'm using 2d divided by t squared. A equals 2 multiplied by the distance divided by t squared. So plugging in my numbers, 2 times 32 divided by 8 squared. As I get ready to plug this in my calculator, 2 times 32 divided by 8. And I want to make sure I press the square button because I only want to square the 8. I don't want to square the entire thing. And my acceleration is 1 meter per second squared. Again, only entering the numerical value. Once I have the acceleration, again, I gave you guys a little bit of a note here. You will need the acceleration from the previous problem. So I need to use this in my data table to help me answer down here in part B. VF is equal to VI plus AT. The initial velocity is 0 plus my acceleration, which I've calculated to be 1, multiplied by the time, 8. Well, VF is 0 plus 8 times 1 is 8. So my final velocity then is 8 meters per second, and that's what I want to put into the Google form. Again, I have the equations there at the top of your paper, and this video will be embedded in the form by the time you guys see it. If you have any questions, please let me know. But good luck. Make sure whenever you're done, look at your score, and the solutions are posted there in the form as well.